Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, let's get started. So I think you must have heard a lot about data over the last couple of days. And I think one of the things that we haven't got into depths to discuss is about how we can promote interoperability by having some standards among different disciplines that's working on the same kind of subject, for example, environmental research. So this panel is about that, the challenges in data standards, and then what are the tools that we need that enables adoption of standards. Otherwise, there is no use for the standards. And so I'm going to ask our panelists to take turns and give a short presentation, and then we will take questions from the audience. Bill, why don't you go first?
All right. Let me stand at the podium just because I get nervous otherwise.
I have to hide behind something as well.
Yeah. So I wanted to sort of take a bit of a perhaps controversial view, partially because I believe it and also just because I wanted to sort of maybe represent something a little bit different. I'm probably not entirely qualified to take this strong of a position, but I'll go ahead and say it anyway. So the idea, from the user side, I've seen a lot of standardization efforts make things more difficult rather than easier, and I wanted to sort of talk a little bit about that. So maybe the claim here is that premature optimization is the root of all evil, perhaps premature standardization is the root of all evil, and this maybe will set the stage for all the reasons why standardization is good, which is what I sort of actually believe. Okay, so me, again, why I'm not really qualified maybe to do this is PhD in computer science and databases and scientific data management throughout. Right now I work at the University of Washington in two positions, as a senior research scientist at this UW eScience Institute and as an affiliate assistant professor in CSE. And I work with all sorts of scientists in all sorts of domains. And previously to that position, I spent 2 years working directly with oceanographers, and that's probably where I had most of my experience interacting with standards committees and sort of implementing standards and helping to define them and helping to sort of evaluate them. And that was in the context of some of these USES, right, these ocean observing systems. So the Integrated Ocean Observing System, which is funded by everybody. If you can name a federal funding agency, an acronym, then it's probably involved in IUCE. And then the Ocean Observatories Initiative, which is similar in goal to IUCE, which is to connect together all these ocean observing assets that have been funded previously, but it's funded expressly by NSF, and the goal is more for basic research than for commercial interests like maritime. But they have similar kinds of goals. It's to sort of standardize the data that's coming out of all these observing assets. And then in particular, the Northwest Association of Networked Ocean Observing Systems is one of the 9 regional associations participating in IUCE, and that's where I had some context. Okay, so I just want to give a kind of a series of statements and some claims and observations, and we can maybe discuss them afterwards. So I claim that standards represent a shared consensus about the world, right? So that's probably not particularly controversial. And so this also, you can make this statement also about schemas and ontologies and controlled vocabularies and taxonomies and so forth. Okay. So I claim that at the frontier of research in science, this shared consensus is by definition difficult to find, right? If we all agreed on exactly what we were talking about, we probably wouldn't be doing research in that area. We'd move on to something else. And so this is where it sometimes gets difficult to say, we're going to take everybody's data output at the frontier of research in some domain and standardize it, right? That suggests that we're able to sort of understand it first, okay? So even if you achieve shared consensus at sort of a global level, I claim it'll be out of date, within a day or so, right? Because of the changing nature of science, okay? So another claim is, no matter, even if we have a successful standard, there will exist data that is not born into existence in standards compliance, right? So if we have to deal with that data anyway, I claim. So if we have to deal with it anyway, why not sort of focus our efforts on dealing with that data and then thereby deal with sort of all data in some sense? And this is a little bit glib for several reasons, but something else is, so I claim the value of a data repository to a first approximation is a function of the amount of data it holds, right? And so I think if you look around on the web, especially in the biology community, there are lots of websites that people have built with public funding that have these great features and can do these great things, but essentially have zero data in them. And the reason is because they had their or many times I claim and I find from talking to people that the reason is because the metadata requirements to put data into the system are so difficult to meet that no one wanted to participate. It was too much of a pain to get their data into the system, so they just didn't do it. And so this is not exactly a standard, but this is still sort of a, top-down prescriptions and constraints can sometimes do more harm than good. Okay, and maybe I claim that further, most data out there is not standards compliant, and so if your value of your data repository is a function of the amount of data you hold, and most data is not standards compliant, then you can infer that we can't afford to reject all the non-compliant data. And so again, we're back to this point of we have to deal with it anyway. Okay. So an observation is that search engines tolerate non-compliant standard data, right? There's a great, very successful standard called HTML, but they certainly don't deal with only HTML data, right? They're able to sort of tolerate other things. And so this may be a sort of a model for how to deal with, for inspiration for how to build software that's considers data that is not standards compliant. So they rely on the standard when it's there, and they rely on the patterns when they're there. For example, PDF files and PowerPoint files and Word documents and so forth can all be parsed and understood by the search engines, but they don't sort of have a top-down prescription and rely on that. Okay. So something else that I talk with people about sometimes is that I bumped into groups, especially in the context of these unstructured grids that I've worked with, where, okay, so unstructured grids, really briefly, people who do ocean models, and there's one kind of grid that looks like a multidimensional array, and it's somewhat simpler, and there's another kind of grid that deals with a bunch of polygons, and it's much more complex. And the interoperability problems for the unstructured grids is pretty severe. People can't sort of compare models very easily, and it's a big problem. And so they were always talking about standards for this, which is a great idea. We need to standardize on that. However, people get really concerned about how you represent the data in the file, full stop, right? So can they capture all the different cases and put it into a particular file format? I don't really think that's the point, right? It's not really about the nouns. It's about the verbs, right? It's what you can do with it, right? Just because you can code everything as a stream of bytes, right? That's a standard for encoding data. You can't do very much with it is the problem, right? So just being able to cram something into a file format, and in particular what we were talking about was taking these polygon structures and trying to put it into NetCDF. And NetCDF is a very array-oriented data model, right? And so there's all different ways you can do that, but it's not clear that any of the clients that understand NetCDF would be useful, right? They all understand arrays, they don't understand polygons, so just by virtue of doing it buys you essentially nothing. And so this is something that I think sometimes people get distracted with is can we capture all the cases in the data? Okay. And so again, you can encode anything in ASCII, XML, relations, RDF. So it looks like maybe I'm low on time. Okay. This is the last slide, I think. So ASCII, XML, relations, RDF, CSV, all these things are sort of, maybe there's sort of a Turing completeness in data modeling or something that we can define, but all these things are that if it exists. And so you want to ask, what does the standard buy you right out of the box? What can you do with it on day one? And so a lot of times what I hear is the promise is, well, it'll be easier to build applications on this in the future once it's standardized. Well, I don't think that's good enough, right? It needs to be easier today to do something, not just simpler in the future for somebody else. Otherwise, the people who are actually producing the data aren't going to have enough incentive to bother doing it. Okay, so I said that pretty much. So these are some of the things that you get out of the box with various standards. And I think a nice example here is KML. You get Google Earth out of the box, which is a very strong incentive to go ahead and put your data in KML. And for some of the things down below, it's not quite clear to me what you get right out of the box. And if you're not familiar with those standards, we can talk about them. So two quick rules, and then I'm done. So what do you do about it? It's not all doom and gloom. Standards are still a good idea. Obviously, we still want to do them when we can. And I think that the two things that I've thought about in the past with people about how to solve this problem is you have to first always make sure you have a reference implementation of every standard you implement, right? So you, the author of the standard, have to provide that. Okay, and so that sort of keeps you honest, right? Because if you start cramming in features and corner cases that you yourself don't have time to implement, why would anyone else be able to implement it as well? Okay. And the second rule is there has to be some sort of a killer app. There has to be something you can do, but once you put your data into the standard, there's something you can do with it right away. And this can be the same thing as the reference implementation, but doesn't have to be. Right? So the point of the reference implementation is to cover every possible feature in the standard. The point of the killer app is to do something useful. Right? So this is the summary, but down there at the bottom, maybe you can skip the 2 rules. The reference implementation must be complete, but may or may not be useful, and the killer app must be useful, but may or may not be complete. Okay, so anyway, that's my view of the standards world.
Yeah, I have it.
Oh.
So speaking of killer apps, it has to please everyone. I want to know, raise your hand if you use Excel to keep your data. But how do you exchange data with, say, other people? Do you just give them Excel, or you exchange in MATLAB logic? Yeah? There is a lot of notion about like sharing the data, and then you need standard, and then boils down to the lowest common denominators. And then, so let me show you a oversimplified slide that we think perhaps Microsoft can help using something called Open Data Protocol. Mm-hmm. And I'll show you that, and then you can take it over from there. So here's a simplified version of how the producers, we see that the data producers may interact with users as a consumer of the data. So say that there is a lot of different data formats out there in the cloud, and if the producer just throw the data out there, and then what the consumer gets is that all kinds of data in different formats, binaries, XML, or flat file, all that. So where is that lowest common denominator sitting, and how can Microsoft help? So there's this open data protocol that Alex is going to talk about, and it automatically supports a lot of, so it's like, it sits below the whole ecosystem of the stack of our products. For example, Azure, SQL Azure Server, and if you put an add-on of spatial tool, then automatically the data could be a open data protocol compliant and creates the OData feed. Or if you implement something really simple, OData SDK, then that will also do that job. And we also have a data market called Dallas. And then you can just simply put your data in that market. And then what ends up is that if users use Excel, and there's a little plugin called Power Pivot, that goes with the OData protocol strategy. And then hopefully the users who has that on his desktop will also add metadata and then add the data back to the store. So that's an oversimplified version of it, and then see that how Alex can expand a little bit in terms of OData.
Okay, so hi, I'm Alex James. I am not a research scientist, so don't ask me any really nasty research questions. I'm on the product team for OData. So I drive the OData protocol. I'm the program manager for that. And essentially, I had a couple of things I wanted to talk about today, but coming back to the point that you made about the killer app, we had this OData protocol, and we were gaining a little bit of traction with it. And then we released Power Pivot, the Power Pivot extension, which allows you to take an OData source or OData producer and bring it into Excel and manipulate the data in Excel and do pivot tables and all that kind of stuff over it. And that was kind of like the catalyst for us, right? As soon as we did that, the whole of the OData ecosystem kind of caught fire. And so that is key, right? I absolutely believe that. The killer app is the thing which will take a protocol to the next level. What I wanted to talk about, though, is some of the challenges that we sort of are facing when we take OData forward, right? So I can do this two ways. I can talk more about OData, or I can talk about some of the standards problems that we are having with OData. And I think I'd rather go that way, but I'm keen to hear what you think. Which way do you want me to go? Do you want me to explain OData in more detail, or?
Yes.
Yes. Okay. So OData then is something that it came out of a product that we created for simplifying RESTful web services, the creation of simple RESTful web services. And that product was called Data Services. And when we did Data Services, we took a lot of care to make sure that we weren't just kind of building something up from nothing. So we made sure that it was, you know, it leveraged HTTP correctly. So we're using, you know, things like e-tags and so forth as appropriate, and the correct status codes and all that kind of stuff. We make sure we map everything to the appropriate things there. We also extended the Atom protocol. Okay, so we took Atom, which is good for sharing kind of document feeds, and we said, okay, the piece that's missing here is we want to share data feeds. So we came up with an extension to Atom to allow you to encode rows of data. And then the kind of like, so it was really, OData then is really just a set of extensions on top of Atom and Atom semantics, which is essentially RESTful, and HTTP. And given that foundation, we now have this kind of protocol which makes it easy for people to kind of share, you know, feeds of data. One other thing we did as well is to make it so that we had more reach. We spent a lot of time working on clients for OData. So the first thing we did is we, along with supporting the Atom format of the protocol, we also have a JSON format of the protocol so that it's easy to consume inside, you know, a JavaScript application. That makes it incredibly easy for people to go and get some data and render it on a page just using a bit of, say, jQuery code. I suppose the other thing that's kind of interesting about OData is we took a lot of time to make sure that we defined clearly the semantics for updates, inserts, deletes, and so forth. So some of the RESTful kind of ideas are a little bit loose. There's some ideas there around, you know, there's this acronym called HATOS, or Hypermedia is the engine of application state, that, you know, that people kind of gravitate towards and say this is kind of what we're going to do. But there's no formal semantics there. And so that was one of the things that OData brings to the table. We know exactly what it means if you do a post to a particular URL and that URL is known to represent a collection. And we know how we will respond. And we're talking about adding some extensions to that, so to adopt, you know, to use existing HTTP standards. As an example is when you update an entry today, you have two options. You can use put-based semantics where you're kind of replacing the thing that you're hitting, or you can use what we were originally calling merge, because at the time there wasn't a standard for this, but now we've just kind of changed that to support something called patch, which is the new, you know, the HTTP verb for patch. So you can apply partial updates to something. So we have these kind of clearly defined semantic paths through your, you know, your application. So that's OData.
Can you just grab the data model a little bit?
So the data.
It's online if you wanted to use your own website.
I'll go without that. Mm-hmm. So typically if I'm fumbling around on a computer trying to find something online, I find that people don't like that.
Yeah, okay.
So the data model of OData is based on the EDM, or the entity data model, which is kind of a way of encoding entities and relationships between entities. So EDM is something which we've been using in a number of our products for a while. And it's now kind of been subsumed by OData, and it's kind of essentially part of OData. And it allows you to kind of model the standard types of relationships that you typically want to do in a more OO style application. So you can do inheritance, relationships, and the relationships kind of that we support are the standard sort of ORM, or object relational mapping relationship types, like one-to-one, one-to-many, many-to-many. And so that's essentially the model there. We have a set of base kind of primitives, which kind of you could map quite nicely to sort of the XSD primitives if you wanted to. So that's OData. And if you want to learn more about OData, I'm talking for 2.5 hours this afternoon about it. So
there is a tutorial on OData this afternoon.
Yeah.
So perhaps you can describe just a little bit of the whole ecosystem of OData support our products.
Okay. So we've, as I said, the OData sort of ecosystem kind of really got wings once we once we had this Power Pivot add-in for Excel. And we immediately, landed some what I would call internal partners inside Microsoft, because Microsoft is like a load of little companies all kind of working in one thing, and everybody's got their own, their own set of goals, and trying to convince people to take dependencies on your stuff is reasonably tricky inside Microsoft as well. But as soon as we had Power Pivot, we landed SharePoint straight away. So SharePoint lists and things like that now support the OData protocol. So you can, along with the kind of the visual UI stuff, which, if you think about that, that's the web application. There's also a web API, which you can use to interact with that data, and they use the OData protocol for that. Dynamics CRM have just announced that they're going to be using OData as well. So you can go off to your CRM data, which is your customer relationship management data, and pull back all your sales information through the OData protocol as well. And one of the beautiful things about Power Pivot is it allows you to kind of mash up unrelated data. So I could go to the sales data in my CRM system and pull that into Power Pivot, and then I could go off to, say, a feed of demographic information in Dallas, which is this kind of like online portal for data, or anywhere for that matter. I could pull that into Power Pivot and then build a relationship inside Power Pivot using characteristics of that data that I know. So I know that this column is the state, and I know this column is the state, so I can build that relationship in Power Pivot and then start doing some interesting kind of analysis. In terms of the ecosystem, one of the things we've got, out of the box, we released kind of .NET components, so you could both create producers of OData and create consumers of OData. But we also, we also have JavaScript libraries, Java libraries, Objective-C libraries, PHP. What else? I think there's a Ruby one. There's a whole ecosystem of clients starting to develop around this. So it means that, one of the real value adds of OData, I suppose, is if you have a kind of a set of useful data, you no longer have to go, if you expose it through OData, you no longer need to go ahead and create all the ecosystem for people to interact with that data. So you don't need to create all the different libraries for all the different target platforms. That's already been done for you. Okay.
Thanks.
Cool.
So Yong, why don't you take it over from here?
Okay. I have just
yes.
a few slides in the.
Is that you?
Here.
Okay. This one.
Panel. Yeah.
Go ahead.
Seems great. Yeah.
Useful tools come first.
Oh, yeah. Good morning. My name is Yong Liu. I'm from National Center for Supercomputing Applications, which is located at the University of Illinois at Urbana-Champaign. I'm a senior research scientist over there, and I have been working on cyber infrastructure, eScience for environment engineering science, hydrology for quite a number of years, and I find myself actually trying to bridge the gaps between data tools and the needs of the scientific community that I work with. So I just want to give you my personal opinions about standards and tools. And I want to start with a news which was just released yesterday. The U.S. Federal Geographic Data Committee, FGDC Steering Committee, just officially endorsed a group of OGC standards yesterday. And there are more than 10, I think probably 20 standards from OGC actually just have been officially adopted, and along with others. So if you go to the web page, you will see all those standards that are recently adopted by FGDC, which was yesterday actually. So for example, like a KML and SensorML and many others. And it happens to be that I'm the OGC representative at NSSA, so that's why I got the news at first place. So one of the interoperability issues that I want to share with you is about groundwater-related data standards, specification, and service. You would imagine that if it's just groundwater data, then that's easy. Maybe that's just one standard or one encoding. But it turns out that there are at least 4 specifications and standards, not official standards, but semi-de facto standards out there to describe groundwater. So there's a groundwater ML from Canada, there's a water ML from US, there's a water data transfer format, WDTF, from Australia, and then there's a rather generic observation and measurement markup language standard from OGC. So they can be all used to describe groundwater, and they have very different formats, actually. Although you can consider they are all XML, but they describe very different features. And there are related service actually can be used to publish groundwater data, or sensor observation service from OGC, web feature service from OGC. So I have been participating in an ongoing OGC groundwater interoperability experiment actually since last November. There are more than 8 or 9 international participants in this interoperability experiment, including USGS, Natural Resources Canada, Australian Commonwealth Scientific and Research Organization, San Diego Supercomputing Center, National Center for Supercomputing Applications, University of Calgary, 34 North, and there's another company from Germany. So the goal was to harmonize all the several existing representations by developing new WaterML 2.0 standard specification, and then also evaluate all these standards or encoding compatibility with existing web service standards such as SOS and WFS. So you can see that even within presumably one subdomain of environment data categories, you would encounter so many difficulties to share, to publish, to consume the data. And we have developed some small tools to just for participating in this IE interoperability experiment, including a KML utility tool which can convert all shapefiles to KML, or water1flow, which is quasi water service to KML, and then KML to RDF, RDF to KML, and those kind of utility tools, so that the people actually can use them relatively easy. And we also implement SOS service to publish groundwater time series data based on SSA own technology, streaming data API, and tuple semantic middleware. So that's all I have. I just want to summarize. Basically, there are so many standards out there. Even within a very small domain, you would encounter so many difficulties. And I think, and I agree, the tools are as important, if it's not more important than the standards. And I think in order to move forward, we need to consider both equally. Thank you.
Thank you. So let's go for Maryann. This is meant to be an open discussion, so feel free to interrupt, I would say that.
Thank you. So thank you very much for inviting me. I actually am not an environmental scientist. I am a neuroscientist, but I run a large project called the Neuroscience Information Framework, which I think has a lot of similarities to the problems that are pretty much faced by any community. As I've existed in the informatics world, I came out of a time when there were a lot of grid projects going on. I used to joke that you could pretty much swap the slides with every single domain because everybody's pretty much facing the same thing.
Right.
So hopefully what I have to say is relevant. Just to give a little bit of background about the Neuroscience Information Framework, this was a project that was inaugurated by the NIH blueprint. So this is the National Institutes of Health, and I've also noticed that there's cultural differences between NSF and NIH, and that's some of the problems that we have here. But essentially it was initiated when one of the NIH directors of one of the neural institutes, so the blueprint is the consortium of all the institutes that have to deal with neuroscience, recognized that nobody really knew what anybody was funding and that everybody was funding databases and they were funding data producers, and people could be funding the same thing 3 or 4 times and nobody actually even knew. Now, we understand that in some cases it makes sense to fund things multiple times, but at least you'd like to do that mindfully instead of just because you didn't know that somebody else was actually doing this. So the project has existed actually for several years. In its initial phase, it was just to survey the state of neuroscience resources on the web. By that time, through initiatives like the Human Brain Project, NIH had invested millions of dollars in creating these resources, and they just said, hey, how many are out there? What is their nature? And so we went on a cataloging journey where a bunch of us, at this time the project was led by Cornell Weiss in New York, and said, well, okay, are there hundreds, are there thousands, how many are there, and what type are they, and how are they being created? And it was very obvious that even though one could say, well, these are neuroscience resources, when you try to draw boundaries between science, especially diverse science like neuroscience, there aren't real boundaries. And so it depended on what you wanted to include as to say how many resources there were. But we were pretty quickly up in the thousands. And it was also obvious that these were of all different types, shapes, sizes, and so that anything that one needed to do to try to bring coherence to this was just going to have to accept the fact that this was very diverse, rapidly developing, there were no standards, and what should we do about it? So the second phase was to actually do something about it, and that's when the contract passed to us at UCSD, and we have collaborators at various universities. So we established the NIF portal, which essentially we say is a way to find neuroscience resources. It also was supposed to provide a consistent framework for describing and promoting discoverability of resources, and that's where this idea of standards comes in, I think. It was designed to work with resources in their current state, so I agree that premature standardization you can't. The technology landscape is actually changing so fast that you pretty much have to grapple with these resources in different sizes. And it was also apparent that a lot of the information that we were trying to find was in relational databases, and that those were part of this hidden web, and so that whatever you did was going to have to be able to search the deep content. So what the NIF portal did was say, okay, we've got information in the literature, we've got this registry, this catalog that we've been doing where we've been going around and trying to find resources, we have structured web pages, we have XML files, we have relational databases, and we want anybody to be able to bring their resource to NIF and make it queryable through the NIF in whatever form it could support and to the maximal amount that it could be queried. So we have tools for taking structured web pages and turning them into something that we can query. We can directly connect to a relational database. We can connect through web services. We basically are very agnostic as long as there's a couple ways for us to access it. And if there's no way or no desire, we just put a listing of you in the registry and say, okay, you're here. We describe you, and so we know where you are. The first speaker alluded to the fact that almost immediately if you're going to try to query across diverse resources, you run into the problems of meanings. And so we've spent a lot of work on developing ontologies for neuroscience. We don't view these ontologies as rigid top-down structures that enforce people to use one or another's terminologies, but we just use them in a sort of a loose sense where we have a thesaurus that sits behind it, so if there's 5 different terms for the same thing, we all map that to the same identifier. If there are concepts and things that are common to neuroscience, we try to define them logically in the ontology so that they can be used. But the query system itself that we put in place does not require these identifiers and things to be in there. That is, we will use them if they're there, but most of the time they're not. But we will use the ontology to help expand search and try to reconcile the fact that since these things were all born when there were no standards, everything is pretty much a mess. We actually believe that one of our major lasting legacies in the NIF is I believe that this was the first time in neuroscientists where they really deeply put neuroscientists, computer scientists together to say, let us actually look at the state of the data. So let's go beyond the hand waving and saying, oh yes, I can use RDF, I can use XML, I can put all these things together, to what are the data that are actually coming out, and what does it make sense to do with it? And how can we make this process better? And again, we're not trying to make it perfect, we're just trying to make it better and expose the things that we found. So one of the things that's quite apparent, again, and I'll spend a lot of time not talking about the sort of underlying, all the acronyms that I call about the XML, the RDFs, the OWLs and things, because to me as a neuroscientist, my main concern is the data itself and the content in the data. And when I talk to neuroscientists about this and others, and when they say, oh, it's impossible, you can't have any standards, you can't do this, I say, well, you know what? Let's think about two scenarios, and let's think about a series of questions. And I say, you know, isn't it reasonable to be able to ask a question of data that's out there and be able to find what is known? So a lot of things that we hear about at this conference and others is like, hey, we'd like to find out what's not known. We'd like to be able to aggregate data, do new analyses on it. But we know that it's hard to even find out what people have found out about things because there's no way to bring them together. So if you ask a question like, is GRIM1, which is a gene in cerebral cortex, the NIF system says, okay, well, you know what? I've got 4 or 5 sources that all export information on brain structures and some sort of expression assay of genes. Now, they don't call it brain structure, expression assay, or age. They call it 5 different things, but it's quite apparent as a data curator that this is what they're exporting. Doesn't matter if they call it geometry, geography, whatever, this is what they're exporting. So if you look at the Allen Brain Atlas, the GenSat, and this is the mouse genome database, you see that they all have some brain structure that's called cerebral cortex. Can we tell that they mean the same thing by it? No, we actually can't. Sometimes they expose their definition, sometimes they don't expose their definition, and there's many different ways to define cerebral cortex. You then look at expression level, and you see that one is 23, one is weak signal, and 1 was actually the number 1, but we translated that to true because we said, okay, we went in there, we found out what their documentation was. And it turns out that when you actually look deeply into these 3 expression atlases, that there was actually no way to compare the 23, the weak signal, and the true, that they were not expressed in any units that you could actually compare with each other. Was this because that was necessary? Well, in some cases, yes, in some cases, no. But what they mostly did, like most resource providers, is they say, I'm going to set up my database, and I'm going to set up something that makes sense to me for my constituents. But I'm not going to think about how this may be used in perpetuity. I'm not going to think about how anybody uses it outside. And I think that this is one of the fundamental transformations that we're seeing. And even though you would think that people who are producing resources are thinking this way, they're not. They've been given money. They're going to serve their constituents. Databases are very good at that because it's good at implementing the data model that they want. They're going to have the pages. And they're assuming that the only way you're going to come to that resource is by understanding step by step what it is that it does, not recognizing that there are nuggets and bits of data in there that are going to be useful outside of what it is that you attended. So we know that there are well-known difficulties in trying to search for this sort of information that are largely because it's inconsistent and sparse annotation of scientific data. There's many different names for the same thing. The same name means many different things. There are what we call hidden semantics. You know, one can be male, it can be present, it can be mouse. There's all kinds of things that are in there. And again, meaning is expressed in units that cannot be compared. And the idea, again, of NIF is that, well, if we can merge this data together, if we can mash it up, fine. But if we can't, there's nothing we can do about it. We don't reject it. It's there. But we try to educate people and say, listen, you know, all things being equal, if you're creating a resource and you can adhere to some of these terminology standards, if you can avoid the symbols, if you can do this, it's far better. It's far easier for us to take your data source and transform it into something else because all the information we need is there. So from NIF's point of view, and I've been very happy in my perusals around the country and things to find out that pretty much anybody who's dealing with a project like this comes up with the same 3 things that are minimum. So if you really want to share data and you want to reuse it, A, you've got to be able to find it. And by that we mean it needs to be accessible through the web. You would be surprised in the number of things that are hidden in attachments and other sorts of things. And people set up data repositories where it's almost impossible to actually get at what they're talking about. You can only go through very minimal metadata. It should be structured or semi-structured, but again, I think you can tolerate a wide latitude depending on what people have, and you need these annotations. You have to be able to use it, so it has to be at least in some form where you can open it and use something with it. You know, we tell people if you're going to publish data in tables, don't publish a JPEG of that table. Yes, we can crack it and things, but it's a lot of extra effort. But again, in our perusals, we have found many people who post JPEGs of tables. You know, that's not the best form. And then you have to know what the data means. So there's semantics. There's the use of identifiers and the context, the experimental metadata. And I think it's very clear when you're talking about, when we were looking at the NIF, that there are different standards that would come into play in all these and that they're targeted to different groups of users. So this is a very long slide, but I think it's kind of important, is to recognize that there are different roles here. And there's the bench scientists, there's resource providers, there's curators, there are informaticians, computational scientists. Each have different levels of skills, different types of skills. Each have different needs from each other. So I'm talking about neuroscientists here, but mostly, again, I'm talking about bench scientists. Neuroscience, by and large, is not a sensor-driven science. We are the long tail of data. That is, most data is produced individually. And we have to recognize that they're experts at interrogating biological systems, interpreting their data, building it into a coherent story, which they often expose through publication. But they are not experts at informatics or structuring information for query and computation. I don't expect them to be. We have to recognize the data are diverse. Experimental paradigms are diverse. They're very difficult to standardize. So I think we have to ask ourselves from the neuroscientist point of view, what is the truly minimum amount of metadata we need from them so that the next groups, the other groups, can do their job. And in a recent conference where I was with a bunch of different groups who were all pretty much doing the same thing, all of us had curators, it was apparent that you could actually boil this down to very simple pieces of information that you needed from the researchers. You needed the species they were operating on. You needed the gene identifiers, not the names that they were working with. And if they were reporting reagents, you needed the vendor and the catalog number. None of this information is standardly reported, but it's not impossible to standardize because we're just asking for these simple things. If you have those, the curators can curate, the miners can mine, the text miners can mine. There's a lot of stuff you can do with it. If you can't, you've got to contact the author and try to figure out what they were talking about, and in some cases, you simply can't track this back. Resource providers, again, I think need to be educated that no matter how wonderful your database is, it's going to be used in ways you didn't intend. And we do recognize that there are decisions that can be made at the outset that will make it easier to integrate. Stable and persistent identifiers are our biggest one. There's a number of times when people tear down their database and pull it back up that they redo the identifiers, and then it's impossible for an aggregator site like NIF to continue to use them. But again, if you're going to communicate about the content, and ultimately, in neuroscience, we're not communicating at the level of data types or anything else. We're communicating at the level of the concepts that tie us together. These community vocabularies, all things being equal, make life a lot easier. And we tell people, they're like, but what if there isn't a community vocabulary? We say, well, then don't use it. You know, I mean, we can only do what we have. We communicate in terms of universals if we can. If we can't, we can't. That's fine. We don't reject the data. It just means we can do less with it. And informaticians, I think, have to recognize that decisions that are made by resource providers that are constrained not by best practices necessarily, but technologies, funding, time, and expertise. We've had so many cases in the NIF project where we've been criticized and they said, how come you did it this way? How come you didn't do it this way? And we said, because at that time, there were no tools to support doing it this way. So we had to make a decision about how to move forward. We are so tool limited in many cases because we don't want to develop everything up from scratch. We don't want to have to be able to do this because if we do, we can't be delving into the content. We wouldn't have aggregated millions and millions of records if we had to develop a new tool to develop this ontology, that ontology, what have you. So we tend to use what's there, which means we will often make decisions that are constrained by this. I think something else that's really apparent going through is that running a production infrastructure is not the same as the typical academic research of standing something up quickly and tearing it down. This was a cultural change that I, as an experimentalist, really had to learn. And it also means that we're not going to change it very quickly because we can't, okay? So if you're dealing with people, every time we make a change in our production infrastructure, it means something breaks somewhere. And so we're not going to do that. That's sort of the antithesis of the experimentalist that most of us are, and this is something we had to learn. Technology is changing very rapidly, And I do want to make the point that we really don't know what the best way to share data is at this point, because we've never had to do it on this scale. And so therefore, again, we don't want to be constrained by saying it has to be this way. We want to be able to embrace a lot of different technologies and things. So finally, I want to also think about, and I talk about this to the neuroscientists too, where when we're thinking about community standards for search, it's a little bit different than when you're looking across resources than when you're building your resource itself. You have to think about how people coming to your resource are going to look at it. And with the ascendancy of Google and Bing and other sorts of things, you're going to type in words and you're going to see what's out there. And if you're going to query across diverse things, you're going to have to be able to have some definition of things like adult, increased, basically the concepts that your domain are going to use to be able to interrogate their data. People ask me this and they say, how come you shouldn't have to define adult because you should give the age? And I said, yes, but neuroscientists deals with worms and it deals with ferrets and it deals with macaques and it deals with mice and squirrels. Does anybody know what the age of an adult squirrel is? You're not going to interrogate it numerically, right? You're going to say, I want things that are reasonable. So we call these sort of the arbitrary but defensible standards because these are the way people are going to interrogate their data first. Yes, the best practice is to provide the age, but you're not going to know what that is. That's why we're so excited about things like Pivot and other things, which will allow us to sort of bring data and then sort of adjust it based on these quantitative values. We'd actually like to get feedback about what people think constitutes adult. So these are all the things that you think about when you're actually looking not at your own individual resource, but you're actually looking across resources. And I think that was it.
So I noticed that most of you are constantly checking the schedule table. It's a little messed up. I think that's probably the reason that we don't get as many people as we expected. It shows on that schedule table that this panel is only 30 minutes. And later on, when they found out the mistake, they told me that I was welcome to break the line there and stay longer. But I think that only a few of you figure that you can break the line and stay with us longer than 30 minutes. But anyway, so given a relatively smaller crowd, perhaps everybody can take ownership and just tell us what you think and what brings you here. Like apparently, if you find this topic interesting, and let us know. Should we just perhaps take turns? We have that luxury today. Just give some thoughts. Testing.
Go in a moment. But on the NIF, are you familiar with worldwidescience.org?
Actually, no.
No, it's run by DOE's Office of Scientific and Technical Information, but it's an international organization of 65 countries where they actually have exactly what you say, the invisible web, as well as, so they do a Google search across these federated databases, and Google finds 4% of what they find. Right. And it would seem to me that you might want to at least talk to them.
Yes, no, I think
because you must have international databases too, but very interesting.
Yes.
And I do have a question about OData.
Sure.
So my fear about OData is that it's a very sensible thing, but unless we get consensus of other companies and other people supporting it, there are many failed standards out there.
Sure.
And one thing I don't want to see is that it's, quote, a Microsoft standard, which people perceive as ours.
So we've spent we're on the road to standardization, be that through W3C or IETF. I don't think that decision has been made, and I know that we're actively discussing it. We're also working heavily with large partners. I can't say names now, but yeah, big companies. Yeah, exactly. And I think there'll be some announcements at PDC. The Microsoft Professional Developers Conference. Absolutely, and we want to go to the standards bodies with strong partners as well.
So, just about that, you can't mention the names, but are they users of the standard, or are they others, or are they providers? Are they people developing features in the standard? In what sense is there a partnership?
So they will be, typically we're talking about producers of the standard.
Oh, producers of the standard,
yeah,
not of
so
data
that
within
essentially increases the importance of the standard. If we're looking at creating with our partners and and just community members have gone off and created, like some people from the community went off and created like the Ruby client libraries, right? So we didn't ask for that to happen, and it just happened. And there's like the PHP and so on. And so there's all these different kinds of libraries that are developing. And so on the client side, I think the ecosystem is almost taking care of itself. On the server side, we're working very closely with, some big players, and things are starting to change there. It's already started to happen, right? We've already got some interesting things. Like, I don't know if you're aware of Netflix. The Netflix catalog is now exposed through OData. So, and that's just opening up a wide range of custom clients. And so this is kind of like the Twitter play. I don't know if the Twitter APIs. They created an API, and they essentially allowed third-party application vendors to kind of grow the ecosystem of Twitter. So, like, if you're on your iPhone, you can choose from one of like 1 to 300 different Twitter clients. The point was that creating that kind of ecosystem of clients is a lot of work, because you have to go off and create you've got your own API, and when you create that API, you have to put up some samples on your developers page that says, if you want to connect using Java, this is how you do it. If you want to connect using C#, this is how you do it. That's the benefit of OData, right? If you go ahead and expose your data through the OData protocol, number one, it kind of reins you in a little bit, which is sometimes that's a good thing. And then the second thing is it means that you don't have to worry about the client-side developers and who's going to create applications for your platform or for your data.
Yeah, Frank, would you like?
I'm Frank Olkin at Lawrence Berkeley National Laboratory, recently at National Science Foundation. I've spent more years than I probably should have working on various data exchange and metadata standards. And let me just mention a couple things. First of all, I've been obsessed for more than a decade on measurement units, which is a common failing of many scientific databases and many commercial databases. And if people are concerned about, I would say the minimal metadata you need for any scientific measurement is the units. And it's amazing how many databases don't have this. And there's I used to go around to database vendors, and I would say, where in the system catalog do I store the measurement units for a particular column? And most people don't have this in their system catalog. But there is an effort underway right now comes out of NIST, National Institute of Standards and Technology at Gaithersburg. Bob Dragasset is the primary author of this, and it's called Units ML, Units Markup Language, and it's being standardized by OASIS, and they just released a new version of this a month or so ago. So if you're exchanging data in XML, you may want to use this. And there's also a thing that's just starting up right now called QUOMOS, Quantities and Units of Measure Ontology Standard, which is also a new OASIS technical committee. I'm co-chair with Steve Ray, who used to be at NIST, who's now at Carnegie Mellon West. And we're trying to get this off the ground if anyone is into ontologies and wants to work on this. There's another standard I would point you at, the ISO 11179 Part 3, Edition 3 is just about to come out. This is a metadata registry standard that is useful, because one of the things, the other thing I would point to is that it's amazing how many databases there are on the web that don't have a metadata registry for people to find out what the fields and schema are and things like this and what they mean. So my classic example, the simple example, is mother's name. That could be the genetic mother, it could be the gestational mother, it could be the legal guardian of a child. And depending on what you're trying to do with it, if you get the wrong one, you're going to get the wrong answer. If you're trying to do genetics and you've got the legal guardian, that's completely useless.
So Frank, let me ask a couple of questions here. So you rattled off sort of 3 standards here. What do you, in all cases, let me be ornery. Is there a reference implementation, and is there a killer app right? What do I win? What do I get right out of the box if I take the time to go put all my units into one of these standards, for example?
In units ML, you have the hope that someone
Hope
downstream
is
can
not good
digest.
enough. Hope is not good enough. There has to be a standard right now that if I take the time, when I talk to people, this isn't me saying this, is when I talk to programmers and I say, you need to use this standard, and they say, why? I have to have a clear answer to that. It can't be the hope of a few, to make things easier in the future. It's got to be because you get to use this application right out of the bag, right? So that's why KML was successful, because as soon as you put your data in KML, you got Google Earth. That's a big win. As soon as you use OData, you get pivot tables. I think that has to be there first. It can't be standards just
Well,
just
but
be
NIST
produced
is
in the
not
world.
in the business of creating applications, so that's not going to happen.
And there we are.
But if you don't use units, if you just pick random ways of encoding your units, you have little hope that anything downstream will understand what you're doing.
So I disagree. So here's why you don't see units in databases, because the entire column is the same units. And so when I want to do something with that data, yes, it takes a phone call, which is a pain in the butt, but it's not as much of a pain in the butt as it is to make that person encode everything in XML in some complicated way. It's just a phone call. So if I want to interoperate with somebody, that's what you're competing with. It's not great. I like data integration. I'm a big fan of data integration. We need to be standardized and so forth. But when you're trying to make a value proposition to somebody that says, you need to change the way you're doing your data, you have to compete with just a quick email that says, what are the units of your data? You know what I mean? And that's a very low overhead thing. It's very simple.
Who developed that is still around.
Okay.
They may have retired. They may be dead.
I know I am. I'm trying to juice up the conversation. I apologize. I'm picking on you.
So I also think that one of the other things that I've learned is that there's a sort of a corporate mentality and an institutional mentality as well, right? So institutions are about things that endure, and that's the idea of having institutional backing. So whereas I agree that for the person who is developing this for their amusement and what have you, you may have no reason to say, listen, you should include a unit, okay? But if you are developing because you've asked the government for money, because you say, I'm going to create this data store, and why? Because people want to be able to use this data, then you would say, hey, you need to put a unit in there, because otherwise you can't use the data, and I have seen that happen. The person who created it is gone. You don't know anymore why it's there. And I don't think that that's a terribly onerous thing to ask them. I don't require that they use unit ML or of these things because they don't exist yet. But if it does exist, I can apply it later as a curator, as long as the information is there. If the information's not there, there's nothing I can do about it.
Actually, I was just going to say one thing. I think that we need, if you are dealing with an application or some data repository which is internal at the moment, and then you're looking to expose it out, outwards, at some point you have to recognize that there's a concrete step with some activities that need to happen there. And it's not just a case of, here's my data. It's a case of, here's my data, and I need to somehow annotate that to provide extra context to the people, outside to explain what I've captured, right? And this is where I don't know this unit ML thing, but is that do you encode all your data in unit ML, or is it
Just units.
So how does that interoperate with exchanging all the data? How do you do that? Is it now two files that are going across the wire? What's going on exactly?
No, the assumption is you would use this in the context of XML-based data exchange.
Okay.
But let me give an example of what happens when you don't encode measurement units. The most famous example.
I think
we know the problems of not having standards.
But this was a famous example. Okay, JPL did everything in SI units, and they assumed that everybody else was using SI units. And I believe it was Lockheed was building the satellite, and they used English units, and they assumed that everybody else was using English units because everyone in Lockheed did. And the result was that there was a mismatch in the software, and this satellite crashed into Mars.
That's fine, but
100 kilometers an hour or
units
something.
ML is neither necessary nor sufficient to prevent stupidity among.
I just wanted to extend what Bill was starting to address, which is which is also what Maryann was talking about, who these standards are for. Because one thing that's missing in this is actually the data producer. And the standards are not actually for the data producer as we're developing them now. And yet that's the person, the researcher, the group that actually has the most impact on whether or not data is can be put into a standard. And so I just like to, so what Bill was starting to talk about is what's the value of putting data into a standard.
So there's
developers, so I'd just like to pose that to you.
Yeah, so there's this idea in development. There's this kind of area called domain-driven development. I don't know if anybody in this room is familiar with it. And one of the things that the kind of the godfather of that, strategy of software development came up with is this idea of the ubiquitous language, right? And the whole point of domain-driven development is to get the business person and the programmer to agree on some terms so that they are working in the same way, that they can communicate effectively. And essentially what we're talking about here is like I have an internal system which has an internal vocabulary and an internal way of working, and I now need to interface with the rest of the world. As soon as as you said, that's a consumer of my data. So I was the producer, and the producer had a certain mental model for how the data is structured, and the consumer has the target consumer has a different mental model. If I just blindly put my data up there without kind of thinking about how I'm going to change the model to for consumption, then I'm not really doing anything apart from creating a nightmare, an integration nightmare.
I absolutely disagree. So I see many more cases of where I can't get the data, period, full stop, because it's not available, right? Rather than seeing data that I can get and can do nothing with because it's so impossible to do. It's hard to deal with it, but I would much rather see every bit of data online in whatever form you have it, at least as a baseline. I still think it's very useful. And again, you talk to machine learning people, they don't give a crap about it. They can figure something out from it even without not knowing much about it. There's patterns in that data, so just making everything available is a monster step forward. It's not enough. I agree absolutely that we need some standards.
Yeah, I don't think we disagree. I think we're talking about scope,
well,
right?
I guess I just get worried about the way the tone will. Maybe sorry, I don't mean to pick on it, but I don't like the idea of recommending to somebody, don't just put your data online until you have it all figured out about the integration.
That's not what I was suggesting at all.
Yeah. And I think you actually pointed to something important, which is that when the producer needs to share it, there's absolute value, right? Because the need implies that there's some motivation to actually share it. But most researchers don't need to share the data. They actually don't tend to not want to share the data. And so, what I'm interested in is what would motivate a data producer who doesn't need to share the data, so doesn't have this kind of innate drive to share, which would then lead to putting that data into a standard. What would pull a researcher?
Comes back to the killer app again, right? Like Power Pivot as an example, just as an example, is like if I can expose my data as OData, then I can pull it into Excel really easily with query support and pivoting and all the things that Excel gives you, and mash it up with other data. So I can essentially create a new database on the fly for manipulation and analysis.
And you mentioned Twitter. That's another example. It's like as soon as you play with the Twitter API, you get Twitter.
And I'd argue, so email was the killer app for that protocol, for SMTP, right? So it's killer app before protocol.
Yeah, that's essentially what happened with OData, right?
Yeah.
Right.
We had this thing called Data Services, which was a product that we created for helping developers create kind of RESTful web services, which provided query support, and so you didn't have to do the RPC style development. And that kind of hit this kind of sweet spot. And then we thought, well, how do we take this thing forward? And we realized that the protocol itself was the piece that was valuable, but it only gained real traction when we had the killer app.
That's a great lesson learned for folks that are passionate. I mean, not many of us here, but we're clearly all passionate about data standards. But if this was a talk about killer apps that data standards enable, you'd be overflowed. So I guess that's my pitch to folks that are passionate about data standards. Where's the killer app that drives the standard? That gets us out of the chicken and egg. I assert that gets us out of the chicken and egg problem.
Yeah, no, I do agree with that, and I also again agree that, and that was really the whole premise of the NIF, is that you make data available in whatever form you can make it, and that other people will go in. But that's where I also agree with Bill in that you want somebody else to be able to go in and massage it. Actually, the first thing that Pivot does. I use Pivot in my own group to show them why I've been harping on controlled vocabularies. Because the very first thing they see is that there's 45 different terms for the same microscope.
That's fantastic. I see that pattern a
Right.
lot too, where if you can feed their own dog food back to them, that's when you
Exactly.
start seeing change.
And you
right?
say, okay, there's 45 different microscopes here, and one is called J4, one is called, and so again, you know, I don't think that there's too many machine learners who know that 4000 number 2 means it's a JEOL 4000 EX microscope, you know, and so, you know, you pretty much immediately show them this is why we're trying to standardize this, the same with units. But what I think it's important for projects like NIF and anybody else who does this is, again, there are motivated people, okay, and there hasn't been anybody to come and say, well, what should I do? Because generally they will either get the hard sell solution where it's like, well, you've got to convert everything into this, you've got to do this, you've got to do this. And they're like, look, I've got one PA2 programmer, I can't do that. So you say, fine. You know, you can say, listen, here are some best practices. Here are some best practices that we can think, because when we come across a source that doesn't do these things, it's just very difficult for us. And these are not, you know, and we're not going to get the whole world that way, but we're not after the whole world, right? It's like if somebody comes to us and says, do you have a good terminology for brain regions? I don't really care what the cerebral cortex is. I'm a molecular biologist. I just want some buckets. And if the answer is nope, then they're going to go, okay, well, I'll just go create my own. If there is one, they're happy to put it in there. Okay, they're happy to put it in there, but you have to know that these things do exist, and if you want to implement them, implement them. If you don't want to implement them, there's nothing we can do about it, and we understand sometimes why you wouldn't. You know, it may not apply to you. You may not, again, have the expertise. So I think we have to be extremely fluid in these things, and we have to recognize there's a process, and I would maintain, again, about publishing data. When you used to publish articles, we had editors, because nobody knew how to format an article. How many people knew how to spell? There were no spell checkers, right? You had to do, you know, an editor came back and said, I don't know what this word means. I don't know what this abbreviation means. And I think for data publishing, there's just going to be this period where people are looking at the data and saying, listen, you know, we don't understand what some of these things mean. We don't understand what this is. And then the tool builders will put them in. You'll have the spell checkers. You'll have the organism checkers.
So just to clarify,
yeah.
You're not suggesting that there should be an editor role between you and publishing your data.
No, no, you can publish whatever you want. Okay. In terms of you can post it on the web, just like you can publish something in Esperanto if you want to. And if there's a translator, great. If not, you know, you generally want to expose it in a way that's maximally useful. But for this step of making open linked data, I think that there is this rolling up the sleeves and going in and looking at the data and say, what does it make sense? Whose job is it to get these things? Because the more coherent and the more annotated your data set is, the more valuable it is to people and the more things they can do with it. I like to tell people that for biological systems in particular, anything that's below 20% noise is going to be lost in the noise because the systems are so noisy themselves. And if you can help smooth those things out by taking out the fact that there's 45 different definitions of cerebral cortex, and at least let people know that there's 45 different definitions of cerebral cortex, then you've done a service. But I don't think that's the researcher. You know, I think the researchers are going to produce data, and again, with units, there's nothing that would go past peer review if you published a paper with numbers and no units. That's the first thing the reviewers say is like, what's your unit? You know, but should you have to translate that into XML or anything? I'm like, no. You should just publish your data with the unit so that something else can take it and express it the way it needs to for whatever purpose you need it.
But the argument is that XML is the way to make that machine readable. Like if you just sort of attach your units, that's not enough for a lot of systems to do what they need to do.
No, but I'm saying the researcher has done his job at that point, or her job. She's published the unit. She said, this is the unit. Something else needs to translate it in. You so just said you should put data on the web in whatever form it is.
I agree.
Yeah.
No, I'm going to reserve the right to flip positions on this.
Yeah. Well, I think we need to distinguish data access and data publishing because we are overuse abuse the word data publishing. If you publish something, that means there's a standard behind it. If you put something on the web, you can access it, you can download it. I mean, that's the data access part. I mean, you can do whatever you want. And many researchers and data providers, they don't have incentive to do the standard. But as soon as we talk about the data publishing, then we must have some standards. And that's basically when we enter the interdisciplinary research areas, we find us in a very difficult position to consume all those data producer produce the data, whatever. Even recently, like, I mean, many commercially available sensors and associated proprietary data logger, they basically produce non-standardized output file. I mean, every few minutes they dump an Excel file without the units, actually. and you need to look it up and ask the installer of the sensor, what units are these measurements? I mean, this is big pain for the consumer, and of course there is no immediate killer app to use it, but for the researchers, for the data consumers, I mean, there must be a gap to be bridged, and I think maybe a data curator and other institutional organization and must take actions to do that. And I think like Microsoft can also play a big role in this kind of assisting this data publishing, just like in the old days when people actually try to publish papers, right? There are publishers to do that. Not like I have a paper written on maybe whatever napkin, and I say I publish it.
So Yong, what exactly do we mean by data publishing? Do we mean a paper goes out with a citation to some data set like an NCBI, or do you mean something different? What do you mean by data publishing?
Well, data publishing, as I see it, is standards-backed.
Just by virtue of it being standardized, that means publishing?
No, there is this notion of data papers. We talked about it.
Yeah.
So that's what you intend.
Well, that's one thing, right? Given a data set, a DOI type of thing is one thing,
okay.
And how you encode the data is another thing. But if you don't give it DOI, you don't give any encoding standard. You just give a flat file with no units, no description, and you say, I put it on the web, and now everybody is publishing data. I don't think
that helps, but let me ask a little more precisely. What's the minimal amount of stuff I need to provide in order to earn the moniker it's been published in your mind?
Well, depending on what kind of data you want.
Okay, so it's complicated, okay.
Yeah. Like I give an example of groundwater. Like the groundwater example, right? It's a perfect example of a very little area that has flourishing activities try to exchange data.
Let's take one question from Huai here.
Well, I'm Huai Wu from George Mason University. I just want to share my experience of data exchange, metadata, metadata clearinghouse experience in geospatial area. It is estimated that 80% or 90% of all the data are geospatial related. So basically, all the data is about where, when, and what. So what part can have a lot of indicators. So my suggestion is like the product like OData, Power Pivot, should have two levels of standards to support. One level is geospatial part, about where and when. And the second level is about what. So the second level actually is much more simple. I mean, not as data itself is simple. I mean, its structure can be like a table, but for the when and where, especially where, is unstructured. So my suggestion is like OData and Pivot can internal support a geospatial structure. Data.
Thanks for pausing.
So actually, we should be joining the crowd for the break and then the keynote there. I think everyone in the audience would dare to break the line on the schedule table, which is really put it around. So we can carry the conversation over there and continue. And thanks again, everyone.
coming on to